Hi, I'm Chelsea, and today I'm going to demonstrate how to split up a fraction using partial fraction decomposition. The best way to explain this is to probably use an example. So let's look at the example I've chosen. So in this example, we have this rational function 1 over the quantity x minus 2 times the quantity x minus 5. And what we want to do is split this up into two separate fractions, where the denominators of one fraction would be the x minus 2, and the denominator of the second fraction is x minus 5. This will help us later on when we try to integrate functions like this. It will allow us to split it up into two separate functions that we can actually integrate. We know the antiderivative. So to begin, what I'm going to do is split this up using a constant in the numerator, a, for the first fraction, and then a second different constant in the denominator. Okay. And this a and b, again, are two constants, and it's what we want to find. Because what we are assuming is we're believing that there does exist an a and a b such that this fraction can be split up into these two. Now normally, when you were learning how to simplify expressions, maybe you were given something that looked like this, but with your a and b already defined, and then your goal was to do the addition here to get back to a fraction that looked like that, or a rational function that looked like that. So we're actually going in the opposite direction. So what we're going to do is we're going to pretend that we were given just this side. And using this a and b, we're going to leave that in there for our constants. We're again going to try to simplify this expression and go this way. Okay? So if I were to find the common denominator here between this fraction and this fraction, it would be, so my common denominator is x minus 2 times x minus 5. Okay? So, looking at this first fraction, in order to have this denominator, we're going to have to multiply the top and bottom by x minus 5 over x minus 5. Again, this thing is really just 1, so we're not changing that expression at all. And we're going to do the same thing over here, but in this case, what we need is an x minus 2. So again, we're just trying to get a common denominator in order to be able to add these fractions. So over here, we will have a times x minus 5. And from this, we get a b times x minus 2. And because we found a common denominator, it's all over the same one. X minus 2 times x minus 5. Alright? The next step I'm going to do is distribute each of these. Okay? So that I get ax minus 5a plus bx minus 2b. Okay, so now that we've done that, we're ready to actually go back and look at what we had originally. Now notice our denominators are the same, which is what we were trying to do. So if our denominators are the same, we can compare the numerators. So we have 1 equal to this whole thing, this numerator. So what I'm going to actually do is just write that down. So I'll have 1 is equal to ax minus, actually I'm going to move the x terms together, and you'll see why in a second. So ax plus bx minus 5a minus 2b. If you recall, the a's and b's are constants. Okay, they're numbers. They can be rational, irrational numbers, but again, they're just constants. So what I'm going to actually do now is just group them. I'm going to bring this x out in front, get an a plus b. And then I'm just going to group this next term. again, bringing down that left side. So this just came from this numerator, so we're just comparing the numerators. So let's see, if you look at this term, it has an x in it. Notice how there is no x terms on this side. So therefore, if a and b are constants, and we're assuming that x is not equal to 0, a plus b must equal 0. To make that more explicit, technically what we're doing over here is we have a 0x being added to that. So we're comparing our x terms, okay, the terms with just one x in it, and we know that that has to equal 0. Similarly, again, this whole thing is simply a number, and our only number on this side is just 1, so we'll get minus 5a minus 2b equal to 1. Okay, so this is ultimately where we want to go. And at this point what we have is two equations with two unknowns. Again, our last goal is to find a and b. So, two equations, two unknowns we can solve. So I'm just going to do a little here. From this one we'll get a equals minus b. Substitute that into this equation, we'll get a negative 5 times a negative b minus 2b equal to 1. And actually, if you are to go through and solve this, you would find that b equals 1/3. Okay, sticking that back into here, we'll then get, because a equals negative b, a negative 1/3. So, we found our a and b, which means that if we go all the way back up to here, to this original place where we had, when we were splitting this fraction and we wanted to find a and b, this tells us that we do the decomposition, okay. This fraction, splitting it up into two fractions each with each denominator, will be a negative 1/3 all over x minus 2 plus 1/3 over x minus 5. And that would be your final. Now, one thing to be very, very careful of is once you find your a and b, when you go to put them back up into these places, they have to match. We can't flip-flop the a's and b's. It's very important that the a sticks with the x minus 2 and the b sticks with the x minus 5. If you were to flip-flop them, we would actually get a different answer. Once you get to this point, you could always go back and try to simplify this expression by finding a common denominator and adding the fractions together. And if you do that, you would get back to your original answer if you have found the correct a and b. And that's it. For more information, please visit our website at www.sandersontestprep.com. The link is in the description box below. Thank you.